Today's lesson is about perpendicular and parallel lines. Number 1. Consider line L1 with equation y equals negative 2x plus 5. The line L2 is parallel to L1 and passes through the point A, negative 3, 4. The line L3 is perpendicular to L1 and passes through the point A, negative 3, 4. A. Find the equation of the line L2. We know for L1, we have y equals negative 2x plus 5. The slope I label as M1 equals negative 2. For L2, since it's parallel to L1, therefore the slope will be equal to each other. I will do M2 equals M1 equals negative 2. Given point is negative 3, 4. We can label this as x1, y1. We can use y minus y1 equals slope x minus x1 to write down the equation. We have y minus 4 equals negative 2. X minus negative 3. Negative will be a positive. So we write down x plus 3. Since they didn't ask you change this equation into specific form, you can just leave as it is. This is your answer for A. For B, find the equation of the line L3. For L3, since L3 is perpendicular to L1, you have to make this negative 2. We take opposite of negative 2, get 2. Then do reciprocal of this 2 will be 1 over 2. Therefore, the slope for line 3, M3 equals 1 over 2. Pass through the point still negative 3, 4. We label as x1, y1. Then for this point slope form, in IB, we call that point gradient form. Y minus 4 equals 1 over 2, x plus 3. This is the equation for L3. Let's go to C. The lines L1 and L3 intersect at point B. Find the coordinates of point B. We know for L1, we get the y equals negative 2x plus 5. For L3, we get y minus 4 equals 1 over 2x plus 3. We want to use graphing calculator to get the answer. Therefore, for this 4, we will cross this equal sign, change the sign. You will get the y equals 1 over 2, x plus 3 plus 4. Don't forget change the sign. We will put this into calculator. You don't have to change this into y equals mx plus b form because they didn't ask you change this one into y equals mx plus b form. So just leave as it is. This one, we will go to y1. This one, go to y2. Then get the intersection. Let's clear the memory. Second plus 712. Then we go to y equals. y1 equals negative 2x plus 5. For y2, 1 divided by 2, parentheses, x plus 3 plus 4, then graph. In your window, if you can see this intersection, which means your window is good enough. The standard window, negative 10, 10, 1, negative 10, 10, 1, you can use this zoom 6 to get this standard window. Then I go to second trace. 5 is intersect, so press 5. 3 enters. X equals negative 0.2, Y equals 5.4. Write down by graphing. We get B, that is negative 0.2, 5.4. Let's go to D. Find the distance from the point A to the line L1. Let's sketch the graph. This is a coordinate plane. So we need to get A, negative 3, 4. Here. Then for y equals negative 2x plus 5. We need to get a 5 here. Negative 2. That means go down to right 1. So down to right 1 is here. Then we connect this. We estimate this is y equals negative 2x plus 5. This is L1. Then from A, we will draw a perpendicular line. Then this is a right angle. This will be B. We already figured out this B. So we could say the distance from the point A to L1 will be the distance from A to B. Therefore, for D, the distance from point A to L1 basically is AB. This is the distance formula. We have A, negative 3, 4, and a B, negative 0.2, 5.4. We will label as x1, y1, x2, y2. Then the distance from A to B, AB equals, plug in negative 3 minus negative 0.2 square plus 4 minus 5.4 square. Negative 3 minus negative 0.2. You can put negative 3 plus 0.2 square, then plus parentheses 4 minus 5.4 square. Enter. You will get 9.8. Then we do square root. Then your answer will be 3.13 at the 3 sigma fix. Distance for AB equals 3.13. For E, sketch a diagram and deduce the distance from the point A to the line L1. This is the diagram for E.